Okay, so in the previous video we are not able to include the electric field part. Let's do it now. Electric field, basically every charge creates field around it. That means if you have a charge here and if another charge is brought near this charge, basically this charge will interact with the electric fields and not with the actual charge. You got it? The charge brought at a particular point interacts with the electric field at the point and not the charge directly. Now, the force that we write is FQE. Now, E basically stands for KQ by R square. So, this formula is same, but we are writing the value of electric field in it. Okay, it's a vector equation, always with sign. If Q is greater than 0, that means that both force and electric field are in the same direction. If Q is less than 0, that means that force and electric field are in opposite direction. So, electric field at a particular point is equal to the force experienced by a unit positive charge placed in that point. That means if a unit positive charge, like 1 coulomb here, is present in a point, the electric field is basically equal to the force experienced by that charge in that point. So basically electric field is KQ1 Q by R square. When you're talking about Q greater than 0, we are saying that the point is away from the charge. When we are saying Q is less than 0, we are saying field is towards the point charge. And even our electric field follows the principle of superposition. Let's take a uniform charged ring on concentration. Basically, you have a uniform charged ring. You use the same logic as you has used in force and you get E net is equal to kx q by x square plus l square cube root. Basically, in this what I am trying to explain you is that if q is greater than 0, then q net is along the axis away from the center. If q is less than 0, then q net is along the axis towards the center. If E center is 0, that means x is 0. So basically E net, if this is 0, then this is L square into 3 by 2, that means L cube. So the value comes to be KQ cube by L cube. Now if this is infinity, that simply means that if this is infinity, the L is so small in front of it that it can be neglected. So we directly get KQ by X square from here. I'm sorry, X cube from here. I'm sorry, X square from here. The X is on top also, I forgot. Now, where can we find the maximum electric field? It is on R by root 2. Field at the center of a uniformly charged arc. Same logic as we have already used. And then we come to this conclusion that E net is equal to k lambda by R 2 into sine theta by 2. Basically the arc, if it's positive arc, the E net will be along the angular bisector and always away from the arc. If arc is negative, the angular bisector and towards the arc. Now, electric field due to a uniformly charged linear distribution. Linear distribution means in length distribution. Here the whole side, the whole side has positive charge. Basically this is creating charges at one point. We can find out the net, that is Ex and Ey. Now the problem is that ऊपर भी सेम अमाउंट ऑफ चार्ज है मिड पॉइंट से, नीचे भी सेम अमाउंट ऑफ चार्ज है मिड पॉइंट से. सो बेसिकली ये जितना नीचे उतना ऊपर भी होगा ई वाई तो कैंसिल हो जाएगा, बट ई एक्स एड ऑन होते जाएगा. ठीक है, समझ में आ रहा है? वैसे ही अगर इसको देखें तो यहाँ पे एंगुलर बाइसेक्टर जो है ये ऊपर वाला छोटा है और नीचे वाला बड़ा है, तो इसमें तुम्हारा जो ई वाई है वो एड ऑन होते जाएगा, इसमें कटेगा नहीं. ठीक है, अब देखो इसका बहुत बढ़िया डेरिवेशन होता है, बट देन हम लोग को डेरिवेशन से कोई मतलब ही नहीं है. हम लोग सीधा बोलेंगे कि और कोई डेरिवेशंस चाहिए तो मैसेज कर देना, हम पोस्ट मार देंगे. हम लोग सीधा बोलेंगे कि ई एक्स इज इक्वल टू के लैम्डा बाई आर साइन अल्फा प्लस साइन बीटा and Ey is equal to k lambda by r cos beta minus cos alpha. Okay, now we come to the next topic, that is electric potential energy. Now you guys might ask me हम लोग questions क्यों नहीं कर रहे हैं. The reason for not doing the questions is basic because that questions can be done later on. If I give you questions right now, after each topic you will know that what logic we have to put in the questions. But if I give you questions at the very end of the chapter or at the very middle of the chapter, where almost you have completed half of the topics or all of the topics, then you might not be able to conclude easily that what formula we supposed to use here. You might think and then use it. Okay. Now here, electric potential energy, again derivation is not important. Still, if you all need it, let me know. UB minus UA is equal to K Q1 by Q1 into Q2 by into 1 by RB minus 1 by RA. At reference, that's at infinity, if we assume the reference to be infinity, that's R1 is equal to infinity, the UA will be 0. I hope you got this. What will be the value of U when we take reference as infinity? U will be K Q1 Q2 by R. So what all formulas do we have till now? And again, remember, another thing will come, that is V, which will basically remove one Q from here. So like the four main formulas that we learned from now till now is force is equal to K Q1 Q2 by R square, E is equal to K Q by R square, U is equal to K Q1 Q2 by R. Okay. See, I already told you, after potential energy you all have a potential, that is V, which is U by Q, which actually makes it to be V is equal to KQ by R. And all these things we are talking about point charges. Please don't get confused. We are talking about point charges right now.